Right, start time. Oh, I've got a cold. So this is about the DAWNSci Eclipse project, which is a newer project come to Eclipse based on previous Dawn presentations that we've done at EclipseCon. And this new project will provide features which are available in Dawn into your Eclipse project. And I will endeavour to show you the classes involved in doing that within this talk. So I'm going to need to sit down because I'm going to flip between code and examples. We're part of the Science Working Group, and I think quite a few of you here are already members of the Science Working Group, but the Science Working Group itself is made up of academic university-type organisations, facilities which are like Oak Ridge laboratories in Tennessee and Diamond Light Source in the UK. Small to medium enterprises such as Kichwa Coders, which is 2 people, and Marantech, I guess that's quite a few more than that. And then there's some large enterprises like IBM involved as well. So there's a good spread of different people involved. At previous demos of Dawn at EclipseCon, I have said that we would one day have an Eclipse project, and that phase 1 of that would be to describe what we were going to deliver, and phase 2 would be to actually deliver an implementation. So what we've done is phase 1 now, and we've delivered a reference implementation. It's open source, but it hasn't been checked by the Eclipse Foundation for all of the kind of IP issues, and that will take a long time. So phase 2 will actually be, as we'll say in the conclusion, lots of small things. We're going to say maybe we're going to look at loading data and then try and get that out open source, and then maybe plotting, and we'll get that open source. And so it's going to be a long process, and we certainly recommend, well, we certainly ask for feedback and improvements, and working with people, and maybe broadening it out to stuff that we haven't implemented, that other people have implemented. So we're trying to be collaborative. We have 3 RCP projects at Diamond. GDA Client, who we have a representative from here, which is Pio. He's one of the developers on that project. It's about 25 developers and support people working on that. And that also includes Data Analysis Workbench Dawn inside its client. But it also has a server which talks to hardware using, and the server and the client communicate using Corba. And the server does things like move motors and detectors and so forth. We have done Data Analysis Workbench. We're going to talk about that today. And there's another project called Control Systems Studio, which is a kind of a project in its own right. It's developed at large institutions mainly, so ITER, DAISY, Keck, NSLS2, and it's used for controlling hardware. And it's an RCP client talking to a database layer. It's quite a big project, but we're a contributor to it as well at Diamond Light Source. The data analysis team, I don't know if some of you won't know this because I have only talked about Dawn previously, but the data analysis team itself is actually not just Dawn. We do lots of other things. One of them is called Dials, which is in the area of crystallography. So when people come along and take their data on a beamline, we'll actually run algorithms on a supercomputer to reconstruct their molecule. There's a very nice video of this on the Diamond website at the moment. That's based in Python, but we trigger it from our GUIs or from our servers written in Java, but actually that's purely a Python product. We also have the tomography space where we run something called reconstruction on GPU clusters. So we have basically numerics that when you want to visualize your 3D data set, it has to, the raw data is not visualizable, it doesn't look like anything, and you have to reconstruct that into the correct data, which is basically a very big parallel number crunching problem. So that's why we use GPU clusters. For that, and we've got some web things, so people obviously need to look at their data off-site, so we have various products for looking at it on your mobile phone or in a website. And so on. There's actually quite a few other teams inside data analysis, but I haven't put them all there. So the product itself, I have shown it for half an hour at previous conferences. But I would like to just show you a little bit about that, because there's a few people probably haven't. Is there anybody who hasn't seen it before? There are a few people at the back, I think. Yeah, so if I just give you a brief overview of that. So it is an Eclipse RCB product. The scientists themselves script it using Python mostly, C Python and also Jython. On top of the RCP framework, using existing third-party APIs, and Eclipse APIs, we've developed our own APIs, the implementation of those are what we're going to talk about today. The users, of course, don't see that. They see perspectives which do the science that they're interested in. But how we're building that is this API layer at the bottom. We've got lots of visual tools, and I'll do a demo of one tool just to give you an idea. It's the same demo that I did at a previous conference. So what we're going to do now is, this is Dawn. You see that okay? Going to open up powder diffraction image. So as well as crystallography, there's something called powder diffraction. Basically, you pass X-rays through a powder and it produces a pattern. And that pattern can tell you information about, although the powder is obviously random, right? It's all different orientations. Nevertheless, scientists can get information about what is in that powder by doing experiments like this. And one of the things that they do is a radial profile. So I'll use that tool just to give you an idea of some of the things they might do visually. So that's what that is it's the sum of the radii in that sector. So it's just adding them all up and then plotting them in one dimension, and then they typically would want to do a peak fit over, say, a few peaks in that. And they get a little peak fitting tool here, and those different peaks they can then export or they can use them. And the other thing we do is all these visual tools, they're integrated with something called the processing system. So you can run, once you've done them once visually, you can run them over stacks of data. But your data must be in stacks, it can't be in a tree, it must be in a big block of data. But if you do that, then you can actually run analysis over those stacks. Right, go back to the presentation. And the other thing we do is slicing data. Again, I've shown this before, but we'll have a quick look at that. So here's a tomography data set, which is a feather, and basically it has a rotational, it's basically a block of data that's rotating a feather inside a rock, and you can use the slicing tools to look at those different slices. And the slicing tools will look at actually how you get them later, but they're contributed by extension point, and they appear in this toolbar. You can do various different slicing, and you can do 3D stuff once JReality loads. I've done it along a bad axis, that's why. So let me do it along a more sensible axis, and it'll be a bit faster. And what I will do is just change Y and X round. Okay, so, and the other thing we can do is add expressions that won't fit in memory. So what I can do here, if I make sure my data's got a sensible name, I can I'm going to take the mean of the dark data as a single image. Probably don't want to view that in 3D, just view it in 1D, I'm in 2D. And I'll take the mean of the white data. Did I forget to call it white? And if I write a further expression, so those two data do fit in memory, but if I write a further expression of the main data set, it doesn't fit in memory. And we'll look at in a minute how, I need to name, it's going to tell me I just typed in a bad expression, but I need to name this the mean of the dark and the mean of the white. And then what I'm going to do is just minus the mean of the dark divided by the mean of the white. So then I've got a much cleaner image. What I've done is, what's happened is they've taken data with no sample in the beam and with no beam. So then you get the information you need to clean up the image. So that's what we're doing here. And you can even kind of export this to video. Got a little conversion service, so I'm going to choose video from image stack, that data set. And I'm going to choose expression 3, which was this expression. And I can do all of that dimension and press finish. Actually, that will take forever, so I'll stop it. You get the idea. I think probably it still writes a valid file, but it doesn't. Obviously, it hasn't done the whole stack. So we'll try and look at some of those tools now. So the DAWNSci Eclipse project is a subset of the features, as I said, and it includes loading, slicing, transformation, mathematics. I'll try and show you some of the mathematics that we can do with this layer. But basically, the design is to mimic NumPy, if you're familiar with NumPy. So here's some very rough and ready example data. It's an ASCII file with spaces between numbers, no header, just lots of columns of numbers. And I'm going to show you now how to read that into Dawn. The file formats that you get by default, I've just copied out of the extension points and put them there. But you can add more, and in fact, people do add more loaders for that because ASCII is a horrible format to actually read in a reliable way, obviously. So obviously there's loaders which are non-ASCII there, but ASCII tends to be the one that has a proliferation of different loaders. So how to load data? You need to use the loader service. I've been told that this is bad. Apparently you shouldn't use the activator, you should use dependency injection. But, so that's on my to-do list to understand what the hell that is. Been to talks on it, but I need to figure out how to do that. But for now I'm getting the services from this activator, and what happens is you ask it for the file, in this case that file of that ASCII file we've seen with the columns of numbers. And because I didn't have any names on my columns, it gives them the name column 1. And then I have something called an I data set. So if I there's a few more loader examples. So inside the DAWNSci Eclipse project, you've got 2 example plugins. There's a numerical one and a plotting one at the moment. Hopefully we'll do a slicing one and various other examples over time. And one of the examples is just loading stuff. So you conjure your service out of OSGI, and then you ask it to load a file, and then what I'm doing here is just printing out the different data sets that we got from that file, and here I'm printing out an image data set, and that's actually the same powder diffraction file we looked at earlier. So that's how you load your data, and then once you've got your data, if it's bigger than will fit in memory, you're going to need to use a lazy data set. So only when that data is sliced does it then exist in memory. And if you've loaded your data into memory, you have an I data set. Lazy data is typically HDF5, and we like our HDF5 to be in big stacks of numbers, so multi-dimensional arrays in big stacks of numbers. If your data's not in that format, you're going to either need to convert it into big stacks of arrays, or you're going to need to write a new loader for loading your data. We like to have our data in big stacks, and then we use attributes within HDF5 which describe what the data is. We have sub-data sets called axes, which then for a given dimension give you a dimensionality. So for instance, if you have 10,000 images and they're all taken at a different time, you'll have another data set, which is an axis data set, and that will be the time that each of those images was taken, for instance. And each dimension will have multiple axes. So here we have a lazy data set, no data loaded in memory, and then here we get a slice out of it. There's a slice object. You basically say the dimensions that you want to slice and the values. Here, the other thing we do have, which is similar to NumPy, if you're familiar with that, is you can take a slice view which doesn't copy the data. So you can actually say, if you've got a very big array, you can say, I'm going to work with a slice of that, but I'm not going to copy it on the slice. I'm actually going to just use it directly in memory using another object. So if I go into examples for that, we've got this NumPy examples within the example. And basically what this is mimicking is there's already a cheat, a web page which shows you, if you're used to MATLAB, how to do your numerics in NumPy. So what we've done is we've got how to do it in DAWNSci. So that's what it is in MATLAB. Here's your matrix, your n-dimensional array. In MATLAB, you go n-dims. In NumPy, I'm told from this comment that you do it in n-dim. And here we have getRank in Dawn. And so it goes on. So we look at different matrices, how to take submatrices, append matrices together, and then do some maths on the matrices, take every other value, and all sorts of different slicing. And then you go right down to kind of a bit more sophisticated analysis where you can do linear algebra stuff. You can do logical law on different data sets. Then you've got decomposition, and for that we use Apache Maths directly. So you actually have to then convert your iData set to a real matrix in Apache, and then you use the Apache library directly. So all in all, it's functionally, there's a few here that aren't actually part of the DAWNSci project yet, so we need to move those over. But all in all, it is functionally almost as good as NumPy. I don't, that's saying quite a lot, because NumPy is a very useful package for those who use this. So the guy who did this has done a great job. Metadata goes along with your data. If your metadata describes axes, as I spoke about before, and you slice your data, the axes will be sliced as well. And when you ask for that axis, you'll just get the slice pertinent to the data which goes with your metadata. It's a bit of a dry topic, but it's kind of useful not to have that happening in 100 places in your code. Instead, it just happens when you ask for your metadata in one place. I did talk about Python interactivity. So iData itself goes to and from Python. I just give you a quick demo. It's a very basic demo, but there are more complex use cases for this. So if we've got this file of columns of numbers, and we plot one of those columns, say, we can actually open that up in NumPy or Jython. So here I'm going to use Python console. This is the PyDev product. Obviously, we haven't invented anything here. We're working with Kichwa coders who have helped us to develop this functionality. We can maybe in the so we've got our Python scripting. We can perhaps go. Why don't I just have something called dmp.diff. So take the differential of column 1. Forgot to close brackets. And then I can then replot that back in the GUI. There are other packages which do this too, but it's a very useful feature. So yeah, you see the derivative taken there. And in actual fact, people actually have quite complex Python, which they then process with their data. And there's an operations GUI which basically allows you to process. So we've just done it for one bit of data, but you can process stacks by just defining the slices that you do on it. So plotting. So within the examples, we've got some plotting stuff. And what that is, just how do you do an XY plot? And there's like a source code for doing that. You get your plotting system, and then you create, in this case, you're going to create a 1D plot. The examples go on to show you multiple axes, bar. And this is all out of the Nebula XY graph project in the underlying layer. But when you program this, you don't need to interact with Draw2D or Nebula or anything. What you're doing is you're just interacting with the data and a plotting system and saying, plot me something. I don't know how you're going to do that. And the idea is to then swap implementations. So we might well swap this for Java FX. In fact, we've got a project to do that at the moment. So here's our image. And we spoke about tools earlier, and the tools work with regions, and regions are basically selectable areas of data, but as well as getting the bit of GUI to modify it, you also get a data layer object which describes precisely that data. So how do you actually do plotting? You have some plotting service which is from OSGI, and you can create a plotting system, and at the moment it's unnamed, and it's just it's not active. So how do you make it active? You need to call create plot part on the plotting systems. This is called when your part is created. You also create a plot part and you put it somewhere on the GUI. And you can plot various dimensions. We've got an ISO surface coming along next year, but you've got the 3D stuff I've shown, the images and all that kind of stuff. Yeah, that's the plotting system. And the regions are a similar thing. So on the plotting system here, I've called it sys. You create a region, and then you say what its color should be. You say what its coordinates are. You set whether the user can move it around. And you can give it user objects actually, because sometimes you need to give clues as to what maths you want to do with a given region, and then you could add it. Tools, which we've looked at, if I show you tools, so that's a region and this is the tool that goes with it, and there's lots of tools as I mentioned. And I'll just give you an idea of how to code up your own tool. So your plotting system is also has a get adapter. It's an iAdaptable, and from that you can get a tool page system, and that's similar to the page system within Eclipse. And it has a few extra things like what's my current plotting system and all this. So on your part you need to have get adapter, and from your plotting system you need to return the tool page system for that plotting system. And then your tool pages are basically just declared by extension point. And the tool page code, I've got, here's some examples of all the different tool pages so far created. And this is an example tool page. And it basically has the concept of a role, which is the dimensionality of data that you're going to apply it to. And it also has the ability to create your own controls for driving your maths in a custom way. And it has a life cycle which basically when the user selects that tool, activate is called, and when they unselect it, deactivate is called. And the idea of that is that you add listeners into the plotting system to activate your tool. So if someone does something in the plotting system, they get an event, then you do some more maths, which is what we saw in the demo, and then you update your GUI for that plotting tool. And then if they then choose a different tool, you get deactivate called, you remove your listeners, and so obviously your tool then stops doing whatever it was previously doing. And the slicing is, again, another XXX system object. So it's basically, it generally exists on a part. I don't really need to create your own version of slicing, but you can create your own slicing tools. So one of the tools recently created was a Hyper 3D tool, which basically allows you to slice into three-dimensional data sets much more efficiently, and to give you data views which you otherwise couldn't get. So on to the future. Thanks. We had 2 pull requests last week, so thanks for that. Yeah, and hopefully we'll get some more, and that can be a way of moving forward. We're not trying to dictate what this should be. What we're trying to do is suggest a way of describing data within Eclipse and manipulating it, and we very much like to get input on the correct design. And it might be then that we change our implementation to fit with that design, and then we support more people will be able to do this kind of stuff. We will in the future move our code from DAWNSci Eclipse repository, which I did earlier this year, to put all of that interface work into a single place. And we'll also extend that. There's quite a lot we still need to put in there. For instance, the operation pipelines and the conversion pipeline tools. And the phase 2, we need to make a plan for that. How are we going to actually IP check 1 million lines of code? We'd certainly take advice on people who've been through that before, and you know. But at the moment, the plan is to divide it up into smaller tasks. We will release an isosurface implementation next year using JavaFX. Again, you just have a trace instead of an image trace. It will be an isosurface trace. And you don't know how the plotting system renders that, but actually under the hood it uses JavaFX. So you can already use that. You just need to check out a couple of plugins and make sure you use Java 8 as your runtime. And then you can start doing some funky stuff like we've done some demos with a dataset which is a skull, and you can sort of look through an isosurface of that geometry, which is pretty cool. And we're going to hire somebody to look after that going forwards. And I mentioned the processing pipeline stuff. That's also going to be contributed in. So, in conclusion, thanks for listening. Tough crowd. And do join the Eclipse working group on this, the science working group. You need to see Andrew Ross, who's the guy in the blue shirt here, if you want to join. And we talk about this kind of stuff on the emails, and you know, it's very productive. And I think you know, we need to do more of this. And you know, going forward, the future looks pretty rosy, actually, despite my deadpan delivery. Yeah. So, anyone want to go for a beer later?
Yeah, sure.
And that's it. Any questions?
You mentioned replacing XY graph with JavaFX, or did I?
Yes. Yeah, that's one possibility. Yeah.
Yeah, I've been looking at the same things.
Have you?
It makes sense.
Yeah.
Yeah.
Okay. So we need to look at that then.
I have a question.
Yeah.
We are having a project where we do JVM monitoring. So we basically get a lot of information about method execution times. So basically, we get like per method X, we get thousands of information of data. And until now, we have really simple plotting stuff. So just like a simple XY plot where we just show the average time.
Yeah.
And for the IP check, we need to change this. So this current library that we use is not supported by because it has LGPL license. And we are searching now for something else. And this seems quite nice because I like this graphs and this option that you can do finding these peaks, because this is something what we also need. Is this somehow the way we should go, or you would say this is way too much for us?
Well, do you
because
need to?
We have a simple case here. I mean, we just
Yeah.
have a time when the method was small and what was the execution time. So basically, it's just a
Do you ever need to manipulate that data? So do you need to maybe fit peaks or on that data?
This would be great, something like this.
Yeah, so you get that for free. If you just describe your data as an I data set and plot it, you would actually get peak fitting for free just by implementing get adapter in your part returning the source system.
I think also the learning curve is quite low.
Yeah. I mean, I saw this example. This is just a few lines, and
Yeah,
this
that's
is
right.
so hard.
You should definitely do
Yeah.
that.
Okay.
Have a play with it. I mean, we're open to suggestions. I mean, it's still a work in progress, as I
It's
said.
too much, sure. I mean, you can do so much, but for us, we
Yeah.
just have a simple case. But if we can show this and have these nice selections and then show peaks and stuff, it's really great.
So you'll be doing something like this.
Yeah,
So
exactly.
you need to define your iData set, and that I guess that's going to change in time because you'll be adding to that data set,
Exactly.
and then what we have is in the iTrace stuff. So it's a line trace. So it'll be I line trace that you'll create. I think there's an append method.
Yeah.
So right, I'm trying to remember how you do it. There's an append way to line trace. So essentially you don't want to replot your entire line, you just want to add vertices going down that series. And then if you want to fit a peak, then you just choose the peak fitting tool. And that's probably, it should be good. Anything else?
Which version do you have as prerequisite?
Sorry?
Minimum Eclipse version.
We are doing stuff in Eclipse 3.8 at the moment. And we have a lot of developers in the 3 different projects. And one of those projects, the Control System Studio, is now moving to Eclipse 4. And that will happen eventually. But it's hard to, we've got to retrain people, we've got to change our code base. It's not going to happen. I mean, what we're trying to do is that this doesn't really change. We might adopt some of the Eclipse 4 designs, but basically the idea of having a plotting system and a trace and an I data set doesn't change. It's long-term design. And that's actually from Pio's group as well, where they want to write code and not know about how it was loaded, how the data was loaded and how it was plotted. They want to be isolated from that because they want to get on with acquiring data on the beamline. So actually inside our company we have that requirement going forward. So yeah, I think we will have an Eclipse 4 target, but it will still be working mostly this way, or with improvements from the community. You know. Okay, anything else? Well, thank you very much.